Yeah, welcome to this session. In this session, I am going to explain how this resistor is represented and how it is shown in terms of connectivity, either in terms of series or parallel. So in this session, we are going to see how this series resistance is represented. So generally, the resistance what we have seen is it is like this, where in terms of theoretical part it should be represented. So here the representation of resistor is somewhat like this, having two terminals. So the terminals like this and zigzag lines which is drawn here, or in some other books it will be shown like this. So don't get confused. This is also the representation of resistors and this is also a representation of resistance, and the value will be given adjacently near that point or block, right? So here it may be a 10k or 100k, or it may be a 1k resistance which is represented like this. So now we are going to see resistors which is connected in series. So what do you mean by series connected resistance? Here is we are having more number of resistance which is connected adjacent to it. So I am having two resistances, R1 and R2. Let me show you how this will be connected. So this is how the resistance will be connected in terms of series. So series resistance is nothing but the terminal of another end will be connected to the next terminal, right? So how to identify the total resistance value here is, in terms of series, you just add the value of resistance given. So R1 plus R2 gives the total resistance, which is sometimes represented as R equivalent. Okay, so here if more number of resistance, here I am taking three resistances which is connected in series, means this is how it should be shown with the end terminals, either it may be A or B, and R1, R2, R3. Let me take this as a 100 ohm resistance, and this is 100 ohm resistance, this is 100 ohm resistance. So what is your R total here is R1 plus R2 plus R3. So it should be 300 ohms, that is 100 plus 100 plus 100, which is 300 ohms. So let me clarify you how it is represented and how it is connected in terms of breadboard. Okay, so let me take a breadboard here and take three resistances. So I am taking three resistances. Okay, so I am going to connect it in series. So let me show you how it is connected in series now. So take one end and connect like this. So here I have used this and this terminology. Again, a series means you should connect like this. So in the same node, insert this terminal, take it another way outside, right? So this is another end. So again I am going to connect in the same point. So this is to be in the same node, and last one. So here if you connect to find the value of resistance across this end and this end, gives you the total resistance. For instance, I have taken same value of the resistance and I have connected here. Let me check it with the multimeter. With one end, yes, I am going to connect it here. Yes, so you could see here the value of the resistance across this potential is 100k. Okay, when I am going to add this with the next terminology, is I am connecting it here, it should be 200. So approximately, as I said, there will be some deviation, so you are getting 200 here. So again the same value 100k is connected. Yeah, I am going to connect across this. So finally a cumulative value of 300 should be the value. You could see here across this end and this end, the value here is 300 ohms. Okay, so approximately 298 ohms. So this is how you can check in terms of resistances, and how the connection should be given in breadboard is also clear. Hope you understood today's topic, how to connect in terms of resistances, how the same node appears. So you could see here across the node potential where I have connected these 3 points. Okay, so this is how I have obtained a 300 ohm value resistance. Thank you.